Morning. Today we are going to see Schrödinger's time dependent equation. And for that, we consider a particle having mass m is moving with velocity a v along the x direction. Therefore, first we have to see classically what it means. Classically, and after that we will see the quantum mechanical treatment. Classically, it is moving along with the x direction, a v, and therefore its kinetic energy, a k, is equal to 1/2 mv square. Okay, so multiplied by m and divided by m, and therefore this m square v square divided by m, and this m square v square is nothing but what? P square is equal to a p square divided by 2m is its kinetic energy. Okay, and let v is equal to its a potential energy, and therefore total energy E is equal to kinetic energy plus potential energy is equal to this p square divided by 2m plus v. Okay, so this is the classically the energy we are going to see. According to the de Broglie hypothesis, this mass m is moving along with some direction. Quantum mechanically, so this is represented by a wave. Okay, and therefore, according to if it is the going to wave, the y is equal to, we all know that a e raised to I a kx minus omega t is a simple wave equation. In that we consider quantum mechanical treatment as y is equal to say si, a wave function. Then we have not known about this k and omega, and therefore we consider another relation is E is equal to h nu and lambda is equal to or p is equal to h by lambda. Okay, therefore E is equal to this h divided by 2 pi and 2 pi nu, whereas p is equal to h upon 2 pi, this 2 pi divided by lambda. So this 2 pi nu is nothing but omega, whereas this 2 pi k is nothing but 2 pi lambda is nothing but k, and therefore put this value here, and we know so this y is nothing but the sine is equal to a as it is e raised to I k, value of the k, value of this k is equal to so this h cross k, and k is equal to p by h cross, so k is equal to p by h cross x minus omega, and value of the omega is equal to h cross omega, and therefore omega is equal to e divided by h cross. Omega is equal to e divided by h cross t. Take h cross outside. Si is equal to a e raised to I by h cross px minus et is a wave equation for the particle equation 1. Okay, now so this is the equation contains E is equal to p square upon 2m plus psi. How it becomes quantum mechanically? So multiplied by psi on both sides, and therefore we get this E psi is equal to a p square psi divided by 2m plus a v psi. Say equation 2. Now we are going to find out the E psi and p square psi from this equation, and therefore first we differentiate with respect to x. Dou psi by dou x is equal to with respect to x, and therefore it becomes it becomes I by h cross a, this I by h cross a, okay, p e raised to I by h cross as it is a px minus et, and therefore is equal to, we can write this I by h cross p a e raised to I by h cross px minus et. So this is the dou psi by dou x. Again differentiate once again with respect to x, we get the d2 psi by dou x square is equal to this I square divided by h bar square p square a e raised to I by h cross px et. So this is the x. Okay, and therefore, so this is nothing but sum. This is the sum is equal to, and this I square is equal to minus. So minus 1 by h cross a p square psi is d2 psi by dou x square. Okay, and therefore p square psi is equal to, so this p square psi is equal to h cross d2 psi by dou x square minus p square psi. So this is the one equation, we find out the value of the p square psi. Okay, so this p square psi. Now again differentiate this equation with respect to t. Therefore dou psi by dou t is equal to, with respect to t, and therefore it becomes minus I by h cross minus e raised to I by h cross px minus et as it is. Okay, and therefore it becomes, so this is nothing but sum, and therefore dou psi by dou t is equal to minus I by h cross e psi. We are going to find out value of the e psi, and therefore this e psi is equal to h cross by I minus dou psi by dou t. Now we convert this I outside here, so this is the minus becomes plus I h cross dou psi by dou t is equal to e psi. So this is the equation, for example, for the e psi. Now put this value of, where it is 2, so this is the 3, say this is the 4. Put this value of the p square psi here and e psi is here, and therefore we have equation e psi is equal to this I h cross dou psi by dou t is equal to this p square psi, and p square psi is minus h cos divided by 2m d2 psi by dou x square, okay, plus a v psi. Okay, so this is the first order Schrödinger equation, say equation 5. So this is the time dependent Schrödinger equation for one dimension. What happens for the two dimensional? So this becomes I h cross dou psi by dou t is equal to minus h cross by 2m into bracket d2 psi by dou x square plus d2 psi by dou y square. So this is the plus a v of psi. So this is the two dimensional, and three dimensional I h cross dou psi by dou t is equal to minus h cross by 2m this d2 psi by dou x square plus dou 2 psi by dou y square plus dou 2 psi by dou z square, bracket completed, v sub. What is this? So this bracketed term is nothing but the del square. We know that. So this is the del square sum. And therefore, I h cross dou psi by dou t is equal to minus h cross by 2m del square psi plus v sum. So this is the three-dimensional Schrödinger's equation, say equation 6. Okay, so once again you see what we did here. So classically, one particle is moving along the x direction, then we find out this total energy. But how quantum mechanical treatment, when we going into the quantum mechanical treatment, so this particle is nothing but the wave, and therefore wave is represented classically is like this. Find out this value of the k and omega, and this omega is equal to E by h cross and k is equal to P by h cross. Put this value here, taking the common h cross here, so psi is equal to a e raised to I h cross px minus et. So this is your the Schrödinger wave equation in terms of the psi. This energy equation E is equal to p square by 2m plus v. So multiply by psi, then it becomes quantum mechanical. We doesn't know this E psi and p square psi. Find out these values of the p square psi and E square psi from this wave equation by differentiating psi equation 1 with respect to x. Again with respect to a double equation, we solve it for the p square psi is equal to minus h cross into 2 psi by 2 x square. In the same equation, when we differentiate with respect to time, we get the E psi. Putting these values of the p square psi and E square psi, we get this equation, that is the I h cross 2 psi by 2 t is equal to minus h cross by 2m d2 psi by 2 h plus v psi. So this is the Schrödinger's equation actually in one dimensional. If the particle is moving in two dimensional, like a plane, this board is two dimensional, one axis and another axis, so x and y. So this is the two dimensional. Three dimensional, like this box, and therefore we know that this d2 psi by x square plus d2 psi by y square d2 psi by 2 z square, and this is nothing but the del square square. And this is a time dependent Schrödinger's equation, since this equation contains p. Okay, and therefore it is called the time dependent equation. It is very important equation, fundamental Schrödinger's equation in science. All time dependent parameter can be studied, all solved using this time dependent Schrödinger's equation.